All right, here we go. Part 2, radical graphs. It's going to be awesome. So you're supposed to try to do this on your own a little bit. It's really fun, actually. Take 0. I'm going to start with this function first. My dog's trying to break into the house here. Leave her outside for a little bit. Take the 0, plug it in. Bad stuff happens. Why is that bad stuff? Well, 0 minus 2 is -2, and you can't take the square root of -2. So 0 is not in the domain. You can't plug 0 in. Sorry, folks. Try 1. Plug in 1 right there. 1 minus 2 is -1. The square root of -1 is no. You can't do that one either. 1's not in the domain. All right, Mr. S, let's try 2. Plug in 2. 2 minus 2. There we go. 2 minus 2 is 0. The square root of 0. What's the square root of 0? And of course, you know that's 0. So finally, anything too smaller than 2 is not going to work here. Because you have to get, this is the first valid number that's actually going to give an valid output. If you put anything smaller than 2, this radicand would end up being negative. That's an important concept. And it's going to affect the graph, which we'll see in a moment. So 3, I'll try 3 next. 3 minus 2 is 1. The square root of 1 is 1. That one worked out nicely. I could plug in 4. 4 minus 2 is 2, but the square root of 2 is not very good. I'm going to skip 4. Try 5. No. Square root of 3 is not going to work. Try 6. Oh, 6 is a good one. What's 6 minus 2? That's 4, and the square root of 4 is 2. So think about what the next good one to plug in would be. Would 7 work? No way. 8? No. 9? No. 9's what we're trying to get. 10? No. 11 works. 11 minus 2 is 9. The square root of 9 is 3. So it took us a while to get there. You notice we got 0, 1, 2, 3. To get to 4, we'd have to be pretty far out there. We'd have to plug in like 18, because 18 minus 2 would get you to 16. So I don't want to have to do that. I'm going to plot. This is enough points I can plot this, baby. So nothing happening here because it's not in the domain. 2, 0 would be right 2, up 0. Right 3, up 1. Right 6, up 2. Puts me over here. Right 11, I'm off the graph a little bit, and up 3. Now you'll notice this graph actually looks exactly like the previous problem. But the curve that's going this way has been smushed over a little bit. How much did it get smushed over? That's how much it got smushed over, 2 units. It's a little weird this is -2 and it got smushed to the right. But we'll show you that again with this. Think about it, the second function now. If you were going to plug in values here, would you want to plug in 0, 1, and 2 like we did here? No, 0's not going to work. 1's not going to work. 2's not going to work. It's not going to be big enough to make this thing positive. 3, 4. The first number that actually works is 5. So you notice I started here going 0, 1. Well, these are silly. 0 and 1 are not going to work. They don't give you, they're not in the domain. They give you a radicand that's negative. 5 is the first one. 5 minus 5 is 0. Square root of 0 is 0. And we're happy for that one. 6 minus 5 is 1. The square root of 1, of course, is 1. So we have to go all the way to 5 just to get this to work. 6 works. 7 is not going to be convenient. 8's not going to be convenient. 9's good. Plug in 9, what do you get? You get the square root of 4. Square root of 4 is 2. Think about how far you'd have to go to get the next valid point here. To make this be a 3 here, what would you need to input? And of course, you can probably see 14 minus 5 is 9. Square root of 9 is 3. So we're way off the graph at this point. So this graph is going to look just like this one, but we have to go over to 5, 0. Right 5, up 0, right there. Right 6, up 1. I'm off by a little bit, that's okay. Right 9, up 2. And I'd have to go way over to 14 if I was going to pull this off. Now, like I said a minute ago, this graph and this graph are the same exact graph. It's just been smushed over a little bit, and it's the same as it was before when we started at the origin, the previous one. How does this blue one relate to that original one when we came from the origin? Well, it shifted 5 to the right. This red one was shifted 2 to the right because of that 2. Right 2 from the previous one, right 2, right 2. Every one of these points gets shifted. If you put a number inside the radical, this question's asking, explain what subtracting a constant, explain what subtracting a number inside the radical does to the graph. And of course, you can see it shifts it to the right. Whatever number you put there, that's how many units it's going to shift it right because it affects the domain. The only way the domain can be valid is if you have a positive radicand. All right, flip the page over. There's another question like this, except this time we want you to think about and predict what's going to happen. Instead of subtracting here, we add. Come back in a minute and see how you did with that.